to the fourth episode of Data Analytics Specialty Exam Series. In this series, I'll be covering real exam questions for Data Analytics Specialty Exam. You will get these or similar to these questions in your exam. This is all free content for you to use. There's hardly any relevant material available on YouTube today on this topic. And if there is anything available, it is paid. So make use of this free content. So please subscribe to this channel as it encourages me to create relevant quality content in the subject area. And this is all free content, so please subscribe. Hey guys, welcome to fourth episode of Data Analytics Specialty Exam Series. In this series, I'll be covering real exam questions for Data Analytics Specialty Exam. You will get these or similar to these questions in your exam. This is all free content for you to use. There's hardly any relevant material available on YouTube today. And if it is there, it's paid. So make use of this free content for your own benefit. Please subscribe to this channel so that you will get notified every time I upload a video in this series, and it also gives me encouragement to create quality relevant material in this subject area. So let's get started. Question number 16. Please read through this question, highlight the keywords. It's a big question, this one, but you can pause the video and read through the question and highlight the keywords. I hope you have read through the question, highlighted your keyword. There is my version of keywords as well. Now, if you see what's the problem on hand here. So what we need is, we're looking for a partitioning approach for improved query performance. We have AWS accounts, cost and usage reports. It's being stored in S3 buckets. Athena is being used. Monthly summary reports for AWS accounts are being created. And that's the key requirement here. Monthly summary reports for the AWS accounts. The queries are getting slower because there's a lot of data accumulation of reports over the last 5 years, and business analyst wants to improve the query performance. Now, we have a tip here on this particular question. It's a very logical question. So let's go through the analysis and eliminate the wrong options and then get to the right answer. Now, if you look at option A, it's talking about changing the format. But changing the format is not necessarily going to improve the query. It might help a bit, but this is not the format. And definitely CSV is not the format that's going to give you any better performance. It's probably going to worsen it. So option A doesn't work. That's not going to solve the problem here. Let's look at option B. Option B is talking about, now the rest of all the options are talking about partitioning the data, which is great because that's what we need here. We have lots of data files in S3, and we want to organize in such a way that the query performance is optimized. And you go back to the requirement, we need to create monthly summary reports for the AWS accounts. Now, if you're saying, I want a monthly report for account A, account B, either you should partition, the combination of your partition should be accounts and the date, and within date we want to do it by monthly and not daily. So month should be part of the partition. So that is a key here. Now let's look at option B. Option B says partition the data by date and account ID. Now account ID is fair enough, but we don't want it by date. We want it by month. So option B is ruled out for that purpose. Now option C and option D are left. Both are doing partitioning by month and account ID, whereas option D is doing partitioning by date, account ID, year and month. Now, order is important, but there is not much, whether we should choose month over account ID. That's not very clear here. We're talking about thousands of accounts, but over a period of, maybe account ID should be the first key, to be honest here, because once you choose a particular account, you're eliminating the remaining 1,000 accounts from the data. But there is one more aspect here. If you just partition it by month, then you're going to get data for the previous year as well. So say, for example, you look for January data, and for account ID ABC, you're going to get for 2023, 2022, 2021. So this is not the correct way, and it fails there. So what you're left with is option D. So you are partitioning here by account ID, and to cater for the issue that we saw in option C, you are partitioning by year and month. So when you say I want the report or a monthly summary report for an account for month of, say, January 2023, this partitioning is going to narrow down the data and make the query performance efficient. So first you will get account ID. So your data is going to be chopped straight away by a factor of thousands, depending on how many accounts you have. Then year, so it will narrow down by year, and then you're left with 12 months to choose the data from and to run your query. So it's going to be an efficient way. So that's the final answer. Answer D, partition the data by account ID, year, and month. Let's move on to the next question. Question number 17. Please pause the video and go through this question. This is quite a wordy question, so take your time. I hope you've gone through the question and highlighted your keywords. So we have to eliminate some of the options here. This looks wordy, it's a bit difficult. Lots of services are being used. Let's look at the problem description first. So we are dealing with the glue ETL process here. Data is being moved to S3. And what we want here is automatic updating the partitions automatically as part of the ETL process. Now we are dealing with partitions here. I think that's one of the key. If you look at option A and B, they're not mentioning anything to do with partition. So that's definitely wrong answers. So option A and B you can rule out because there is no mention of partition there. Now, if you look at option C and option D, both are dealing with partitions. Yeah, I have highlighted the keywords for you because as I told you, this is a difficult question. So we kind of really analyze each option to get to the correct answer. So option C and option D both have partition related references. Looks like there is some feature available that you can use in Glue update. There is mention of enable update catalog, enable update catalog. Then what's the difference? Option C is using Hive Metastore and option D is using AWS data catalog. Now, another kind of exam tip for you. In any question, you should always use AWS provided built-in feature, and you should keep the number of services to minimum. Now we are already using Glue ETL process. So if there is a feature available that Glue itself is providing, you should use that. There is no need to then introduce another server and increase the cost, because you see there's always that requirement of most cost effective way you want to meet, solve this problem. So Apache Hive Store is going to increase your cost because they are introducing another service, whereas use of AWS Glue catalog as method, to manage the catalog and use it as as a service for partitioning is the right answer. So you rule out option C, and what is left is option D, and that's the final answer, option D. I will also show you the documentation around this feature, and I'll be putting a link for this in the video description later. So this is AWS Glue documentation around partitioning. If you see your extract, transform, and ETL job might create a new table in partition in the target data store. And I think there is mention to the method as well, enable update catalog and partition key as an option argument. So you can create new partition, update partition. I've just showed you new partition here, but if you go to this link, you can see all the methods that are available. So that's the answer, and that's the supporting documentation. Let's move on to the next question. Question 18. Please pause the video and go through the question, highlight your keywords, try to understand the requirement and the problem statement. All right, I hope you have gone through the question, highlighted your keywords. So what are we dealing with here? So we want to use a Metastore using least operational overhead. And we have given option of AWS Glue Data Catalog, EC2, RDS, and S3 as Metastore. Now, again, the tip for you is always use AWS provided built-in features and minimum number of services. And there is a feature that AWS Glue Catalog provides if you're using Amazon EMR version 5.8.5.8.0 onwards, that you can use AWS Glue Catalog itself as a Metastore. And I'll show you the documentation around it. So this is the link. And it does mention that you can use the AWS Glue Data Catalog as the Metastore for Hive, as long as you are using Amazon EMR 5.8.0 version or later version. And that is the key to this, solving this problem. So if you go now to see, do we see that as an option? Yeah, we do see option A. So rest of the options Whether they will work or not, I don't know. They may work, but it's not going to be, least operational overhead, as well as it's not going to be cost effective. So B, C, D are wrong. Option A is correct. Final answer is option A. And that's how you get, you solve this question. Let's move on to the next question. Question 19. Again, a very, very big question. So please read through this, identify the keywords and highlight, understand the requirement. Okay, I hope you've gone through the question, highlighted your keywords. I've highlighted some more keywords. This is one of those that you have to really read all the options and eliminate. So we are going to go for elimination, and you can already see. So the problem-wise, what we're dealing with here. So we have compressed files. They are being copied to S3, and we need up-to-date reports and ad hoc queries to be run in a cost-effective manner. As long as, and we by up-to-date, it means when the data is uploaded to S3, we would like, that record to be available as part of the analytics reporting. And for one-time queries, we want better performance as well. Now, we are already using S3 here. Solution-wise, I think one of the rule is always use AWS provided services and built-in features. Don't introduce any costly services. And if you look at option A and B, I can already see Amazon EMR being used as part of the solution over here, and that's very costly. Amazon EMR is a super costly service. So that I'm going to rule out based on the cost option itself. So those are out for you. Now, again, I'll reiterate the tip for you is always use AWS provided built-in features and keep the services to minimum. Now, option C and option D, both are using Amazon Glue, and then we have in option C, AWS Step Functions and Spectrum, OpenSearch. So Amazon Redshift is very costly service, and Redshift Spectrum is very costly as well. So this is option C is going to be much, much higher cost than option D. Option D, it's using AWS Glue, which is already part of the solution. We're using Lambda and S3 notification. So we're using basically built-in features of S3 to make sure that data is up to date by sending event notification, and then using Athena and QuickSight for analytical reporting and dashboards. So this is much more cost-effective solution because you are using cost-effective services, as well as you are making use of existing services features to cater to the requirement. Like this event notification caters to the requirement around up-to-date listing as soon as the data is uploaded. Also, QuickSight is pretty economical. Athena is also an economical solution. So based on the cost between C and D, we rule out C and we go with D. That's the final answer. Answer D. Let's move on to the next question. Let's look at question number 20. Please read the question and highlight the keywords, try to understand problem description. Please pause the video and go through the question. All right. I hope you have read the question, highlighted the keywords. So what's the problem description here? So we have a technology company which has an application with millions of active users. It's a big keyword, millions of active users every day. And Amazon Athena is being used to understand how users interact with the application. The data includes date, time, stamp, location ID of the users and the services they're using. We need to run the queries and have lowest latency possible. So this is the problem where you have lots of data, data from millions of users. You want to make sure you run queries to understand their behavior pattern, and you want lowest latency. Now, if you see, the requirement here then becomes like how data is stored, which is data format, and then how are you partitioning it. Now, you all know in big data world, if you need to use any format, you should go for columnar format. We have looked at in previous videos and gone over the benefits of columnar data format. It's efficient. You can choose the columns you want, not deal with unwanted rows that comes with a non-columnar data format. So if you see option A and D, both are not columnar. So you can straight away eliminate it. Avro and CSV, it's not going to fit the problem statement here. So we are left with option B and option C. Now, you see, how's data organized. So we have millions of active users every day. So, and then every day they have some set of activities, a number of rows. So if you want to organize this data for better query performance, you will have one of the first partition by your date. Date should be one of that, and time if possible. Then that will narrow down the data to a smaller subset, because every day you have millions of active users. And then you can go for a second parameter, something of a product key. In this case, location ID is there. Maybe then you sort them by location. Now, if you look at option C, it is first of all using ORC format, which is not a issue. It's still columnar, but the partitioning is happening on location ID first and then date and time. So when you partition on location ID, you're not going to get a good subset of the data. It will still have huge number of records. Whereas if you partition by date and time first and then by location ID, like sort by location ID, you're going to get an optimum organization of your data, and that's the correct way of partitioning for this scenario. And that's how you will get lowest latency when you're looking for a particular user's service on a particular day. So you chop by day first and then sort by location, you get to that user very quickly. So that's the answer B. So you rule out option C on the basis of incorrect partitioning criteria, and option B is a data format is correct, it's columnar, and the partitioning criteria is perfect as well. So that's your final answer B. So that's it. That brings us to the end of this episode 4 of this video series. Please subscribe. If you like this video, please subscribe to the video, and you'll get notified every time I upload a new episode on this particular topic. So thanks for watching, and I'll see you in the next installment, episode 5 of this video very soon. So please subscribe, and thanks for watching. Bye.